So good afternoon. Welcome to my session about crafting domain-specific languages. Subtitle is A Practical Guide. So it will be a round trip through all kinds of aspects in language engineering, language design. And for that reason, I will do this talk a little bit differently than I used to. It will be maybe a bit faster, going through a lot of aspects and not focusing on a single one. And so, yeah, let's get started. I am Miro. Shortly about us, we do focus on innovation, open source tools and frameworks all around IDEs and DSLs from Northern Germany. So DSLs, domain-specific languages, that's the topic for today. Let's start with the first step in the process of creating one. Why would you even do that? And so I would just want to mention a few key points, a few keywords here. That are typical examples of why you would do that. I think there can be more, but so it's basically about communication. So it's in a complex business, complex domain context. You have communication and complex. You want to convey complex matters to each other. You want to be consistent with that, and you want to reduce mistakes. And at the same time, you want to automate things. You want to save time, reduce costs, increase efficiency. And while doing all that, you want to lower the barrier to entry and make it available to employees with non-technical background. And yeah, want to integrate the tools so that they can be used efficiently. And so these are some of possible goals for even starting such a project. And there are many examples that can be explained much better if you're in a specific domain. Then it's, of course, easier also to make the specific use of that, but here we are on a domain independent level. And the next question then is why text? Because yes, there would be other ways to represent information, but with text, it's a really good way to focus on the vocabulary of the target users that you can integrate directly into your own language. You can formalize syntax and semantics. So you can make it a formal language that is really well processable on the automatic level and also understandable by the users. It's text, so you can copy-paste it. You can put it into emails and chat, anything else, so it's just plain text. I mean, of course, you also want excellent tool support, and that level it's more than just plain text, yeah? So the language is understood, and the tool gives you feedback and completion and all that on the same level as you know it from programming languages. But it's also, of course, no problem to just copy-paste it and it's still understandable. And you can use it with standard version control. So you can diff and merge it, and this is a great plus, for example, compared to doing the same with an XML-based syntax. So now looking at implementations or frameworks, now there may be other alternatives, but now looking at in the Eclipse context, the main framework that was started in earlier time was Xtext. It targeted the Eclipse platform initially and is based on the Eclipse modeling framework, EMF. Then later in 2016, we extended Xtext to also support the language server protocol, and with the goal to make it available for other platforms. First, Visual Studio Code, which is the platform that introduced the language server protocol. But then it's also available for IntelliJ platform or for any kind of web application. So the language server protocol was the key enabler to move it into other IDEs and other kinds of applications. There were attempts before that in the Xtext project to make it available in other platforms, but it turned out that the effort is just too high to make it happen. And with the language server protocol, we finally have a means to make it to do the same with much less effort. Then in 2021, we started the open source project Langium, which directly targeted the language server protocol from the start, and with that, we have the same advantage. And Eclipse, by the way, also supports it. So there's the LSP4E project for that. So now in 24, we are at OCX. What should you choose? I think there can still be good reasons to go for Xtext, especially if it's important to you to integrate with the EMF framework, integrate with other tools on that level. But in most cases, I would say Langium is the better choice because it's web-based, and I will also name a more particular advantage later on in this web application context. So let's now dive a bit into language design. So the process before you go into the deeper implementations of really defining how the language looks like. And yeah, the question stated here is one that you should probably always ask before starting a software engineering project. What's the problem you want to solve? But I think it's also particularly good to have a good answer to this question when you dive into language design. And so let's think about what is your language about. And this can go into multiple different paradigms. And for example, there can be structured data inside, which would be kind of an alternative to XML, JSON, YAML or so. There can be relationships described, so describing a graph, and you can do graph analysis on the resulting graph. You might want to visualize it in some way afterwards. Or it can be focused on constraints, maybe logic constraints or numeric, so that can describe some nice aspects that can be analyzed in a more mathematical way. Or it can be about behavior, which is more the direction of programming that we know as software engineers. And there again, we can have an imperative paradigm or functional paradigm. And your language can take one or more of these paradigms and mix them in a unique way, in a way that makes sense for the specific purpose you want it to solve. Yes, for the specific problem you want to solve with that. In general, if we simplify this to a single line that spans from very specific to very generic, we have to say we have to choose an abstraction level. And on the generic side, it means the language might become very complex, very expressive. You might have mixed paradigms. And the risk here is if the abstraction is too high, well, then you might as well just use an existing general purpose language. Why do a specific one? Why do your own one then in that case? On the other hand, if you go too far to the low-level abstraction, the resulting language might be simple, restrictive, using a single paradigm, and in the extreme case, it might be not that useful. So we really want to find the sweet spot, and where it is really depends on who are the target users, what's the problem you want to solve, and so on. But I think it's really important to get this kind of question before you even start designing anything. Then, also as always in software engineering, it's good, or in product design maybe, it's good to think UX first. So in the context of languages, I would say speak like users and think like users. So thinking in this context means you take the concept, structure, expressiveness, complexity, and put them into suitable paradigms that describe how the language looks like and what kind of information goes into it. And speaking like the users, on the other hand, is taking the vocabulary, the acronyms, the established language in that domain, and that, for example, can go into the keywords. So the keywords are the fixed part of the language, and those can be very specific, and they can be made, those parts that glue everything together and that are well understood by the users that you want to target. Then from the way of working in this, prototyping is super important. And this approach applies the same also for Xtext, but I wrote Langium here as because it works here as well. So with using the grammar language that is defined here, we can develop a prototype DSL and ship it early to a selected group of customers, discuss it with them, and then work on the feedback. And this can be done in an iterative way. And it works really well because of the way the entry point for designing these languages works. It's based on the grammar language. And I can't dive too deep into how that looks like. Just want to show a very small example that shows a single rule description. This kind of state, it's part of a state machine. So a state with a name and transitions. And what this grammar language does is it serves two purposes. So that's why we call it the duality of the grammar. The first one is it defines the textual syntax, which gives us, on the mathematical level, a context-free grammar, like a rule that is defined as keyword state, then an identifier, which is some kind of name, then zero or many invocations of the transition rule, and then a keyword end. So that's just the syntactic level that is used for the parser. But then there's also a data structure. You could also call it the semantic level, but I think it's a little bit before the actual semantics. It's more the data structure that results from it. And here, if you describe it in TypeScript, it's just a single object with two properties, name, which is a string, and transitions is an array of transition. And that's what we call the abstract syntax tree. Now, when you're prototyping, this form of writing is really nice because you define both aspects, so the syntax and the data structure in one step. And so you can write and change based on the feedback very quickly. And you get a lot of out-of-the-box functionality with that because the framework can already generate a lot of stuff based on this definition. And you get an editor where you can start typing, and you already get completion for these kinds of keywords that you've defined here. And you get validation whether the syntax is correct. But when you transition to a more mature implementation, at some point you should define the data structures explicitly. And for that, we define a syntax in the grammar language that is similar to TypeScript. In this case, we use the interface syntax, where we explicitly define the properties that we want to create in the process of parsing our text. And what's nice here is that if we make a mistake, for example, we change the assignment of transition to a single one, not an array of transitions, then we get an error in the grammar editor saying the type doesn't match. So just as one of the examples. So you already have a static validation that your syntax conforms to the meta model that you described. Yet, just a few more hints on this level of designing the grammar. So when you want to describe constraints to your language, usually you should do that in validation, which is an additional step that runs on the abstract syntax tree. You should not always do that by making the grammar too strict, because with validation, the nice thing is you can provide much better error messages to the users when they violate the syntax. I mean, this again is something that is better to explain on an explicit example, but just want to mention them rather quickly here. Another point is if it's ambiguous for the user, it's also, or if it's ambiguous for the parser, it's also ambiguous for the user, which means you should not fight the parser too hard to make it work, even if it's ambiguous, but maybe rather change the syntax so that it's clarified. Because remember, it's a format to be used by machines and humans. Then it is possible to create languages. Oh, wrong button. It is possible to create languages that are whitespace sensitive, or also languages that are case insensitive, but I would not recommend it. So it's just based on experience. I think it's better to keep whitespace, like in most modern programming languages, just as a readability hint for the user, and have an exact matching for names and identifiers instead of this case insensitive approach. Now let's move on to the implementation part. So implementing the language, so now this goes more towards, we have defined the syntax, how it looks like in text, but now we go towards what does it mean? So we add the semantic meaning of it. And this is really interesting, and we progress from enhancing the syntax by defining cross-references up until we come to execution, so to something really interacting with our environment. So first, cross-references. Here's an example from the same context of state machines, which is quite easy to explain. That's why I often take that as a running example. And so we have a transition definition that defines when this event happens, then go to this target state. So on the grammar level, we have two cross-references defined by these square brackets. And syntactically, it's just identifier, arrow sign, identifier. So the parser only sees these names and this keyword here. But on the semantic level or the data structure, we get a property event, which is a reference to an event, and a state, which is a reference to a state. So, and what the framework gives us, and this is also the same with Xtext and with Langium, the framework gives us a a built-in way to resolve these references so that when we navigate the AST, we can follow them and have a really nice way to analyze things, to have custom validations, to have custom way of traversing our data. So how do we resolve them? So the first ID is an event. And so in order to resolve it, we need a scope, which is a collection of symbols that, and this scope should point to a list of events defined in the surrounding state machines. While the second identifier points to a state scope, so a selection of states defined in the state machine. So although both are syntactically just IDs, they mean different things. And we have that in programming languages too. So we have some identifiers mean this is a variable, and this another identifier can mean this is a type. So we have different kinds of scopes there as well. Now, these scopes can be nested, so your AST can be very complex, and in that case, these scopes as well need to be resolved in a hierarchical way. So if we don't find the reference target in the directly surrounding scope, then we have to go one level up, see if it's there, and if not, go another level up, and up until the root. And if we don't find the symbol there as well, then we look into the workspace in other documents. And that we call that the global scope. So all this lookup needs to be very fast. And so there is also built-in ways to make that fast. Like in Langium, we collect lists from all the symbols defined on every level, for example, so that we can build these scopes very quickly. And on the workspace level, we have an index, which is essentially a hash map of all the exported global symbols. And optionally, you can also add some customization, for example, filtering these global symbols so that the user can only, or the local document can only see those symbols that are imported. For example, if you have explicit import statements. But by default, all global symbols are imported. Then there's the topic of type systems. So you might not always need this. It really depends on what is in your language. Let's say you have a language with expressions, and you also support this dot operator that you know from many languages, many programming languages. What does it mean? So we have different things we have to consider here. One is cross-reference resolution. So in order to, what we have to do here is first resolve this reference to the symbol SM1, then identify the type of that symbol target. So and we should assume that is some kind of structured data. Could be a class or something like that. And then we can look into the definition of that structured data to find a property named initial state. And so what this means is that your scoping, which you need for the reference resolution, may depend on type computation. So you may have to resolve a type, to compute a type first before you know what initial state is and to what it resolves to. Another example here, it's an assignment. So you might have some sort of assignment, either imperative or declarative. And here you want some type checking. So you first infer the type of your right-hand side. Then you determine the type of the variable you want to assign it to. And then you check whether the types are compatible. And so this type of validation, it's a special kind of validation, also requires type computation. If you want to know more about this topic, my colleague Johannes, who's sitting here, will talk about it more tomorrow in the afternoon. So we're introducing a TypeScript-based library explicitly for this to make it easier to get started into type system definitions. So for the IDE integration, I already mentioned the language server protocol and mentioned that it can work to connect your language to multiple IDEs. The underlying protocol is JSON RPC, obviously a JSON-based protocol, which is, by the way, very flexible, can also be used for many other things. It's really nice. And what you get with the frameworks like Langium is abundant built-in functionality. So even without adding more code to it, you already get a lot of functionality in the text editor, but you can also customize it. You can adapt the code completion and many other features of the text editor exactly like the users, like you want it, or better said, like it helps most the target users that you have in mind. And what you can do specifically with Langium is a direct integration in a web browser. So let's imagine you have a website, and now you can integrate a text editor widget there. So for example, you can use the Monaco editor, which is the same that is used by VS Code. Or there are also other web editor or text editor widgets for the web. And now you can run Langium in a web worker, which is, you can imagine, like a separate execution thread in the background, but within the browser. So it's still loaded by the browser from the whatever website you're viewing. And then it runs locally on your machine, on the browser, and interacts with the text editor, so you have immediate feedback. So there's no backend connection required, so you don't have any delay caused by communication to some server component. And also you can save a lot in server infrastructure, because this is all done on the client. And this is because Langium is based on TypeScript, which compiles or transpiles to JavaScript, and it all runs in the browser. So now to the most interesting part, in my view, which is, let's get this on the road, let's get this really running somewhere and execute something meaningful. And there, I want to present 3 approaches for it. The first is an interpreter. What you do here is you take your abstract syntax tree, your data structure, put it into this component that we call an interpreter, and that is an implementation that looks at the content of that data structure dynamically and derives some behavior from it. What it means, of course, depends on the semantics of whatever you have done. Is it something functional, something imperative, or logic programming, or whatever? So depending on the meaning, you have to implement that. And then this interpreter can interact with the environment, and that can be interacting with some server application in the back end, or maybe it can run inside the IDE, so it can interact with the user through the IDE. Or it can run on an embedded device, or on a terminal, or many other ways where such an interpreter can run. What's nice about this, there is no build step necessary. You just take you just parse the text, you get an AST, and you execute it. That's it. So that can lead to very fast execution cycles. If you integrate that in the IDE, it can mean you type something in your text editor, and in the background, you interpret that, and you see some results in a side-by-side view. And that can be really near instantaneously, of course, depending on the size of the project, but you can have a really nice user experience there. And one thing that might be really important in some contexts, the security is guaranteed by the very restrictions that you have put into your language. Because you have defined the language, you define what is possible with that language, and so this interpreter can only do what is possible with the language. Yeah? There's no way to break out of that. On the downside, the implementation effort is relatively high for this, depending on the complexity of the semantics, but it is still relatively high. It's relatively hard to debug the interpreter because you're working on a high level of abstraction. So the debugger is looking at an instance of the model, and you have to debug through the interpreter code. And there's additional effort involved if you want your users to be able to debug the DSL. So if you want them to be able to set breakpoints and step through the DSL code. It's possible, but you have to write your own debugger and debug adapter for that to connect it to the IDE, which is, you can't use anything that is already ready for that, I think. Yeah, and this is different with a second approach, a code generator, or you could call it a transpiler. So here, the code generator component can execute, can take the AST and create some target format. It could be executable code in some language like Java or C++, or documentation, or data, structured data in some form. So the nicest thing here is you can, of course, have multiple generators, so you can target multiple output formats, which means the DSL is the single point of truth, so the single entry point for your users, which connects to multiple services. It can be, so the behavioral parts can be executed, the data-driven parts can be synchronized to some database or other services. You can also use existing libraries in your target language and interact with them. And what I mentioned about the debugging, depending on what target language you're using, you can provide a really nice debugging experience by using the source map mechanism of that target language. JavaScript, for example, has a concept called source maps. And in C++, you can use hash line preprocessor annotations to do that. In Java, you can manipulate bytecode to insert the correct source mappings. So for these examples, it's possible to have debugging experience where users step through their DSL codes. Yeah, on the downside, if you want to write unit tests for such a code generator, it usually means you have string comparisons, because the generator creates strings, and so a unit test for that is compare the string with this expectation, which is not the nicest way of testing, but it's okay, it can be done. And yeah, the last thing here that was mentioned, there was in some specific cases there can be a maintenance risk, and specifically when the structural difference is very large between your source format and your target format. Okay, I could talk a lot about that as well, but let's move on because I want to give a walkthrough and not a specific topic. The last approach is a compiler. A compiler means we want to target directly executable machine code. And this can be done, for example, using an open source framework called LLVM. It's a project that is quite widely used. It has a vibrant community, even its own conference. And for example, the Clang compiler is from that project, and also the ClangD language server, which gives C++ support for modern IDEs. And what you do here is you write the so-called compiler front end, which takes your DSL in form of the AST, the process data structure, and you generate an intermediate representation, it's called IR, that is defined by LLVM, and there are libraries to do that. And from there, the already existing LLVM toolchain can be applied to apply optimizations and generate binary code for multiple machine targets. So it can be Intel, ARM, or even WASM. And this approach gives you lightning fast execution. So this is really for optimizing the execution speed up to the maximum possible. You also get very precise control of the binary output that you have at the end, and also fine-grained information for debugging. So you can really have the mapping from the source to the binary instructions already interweaved into your intermediate representation, and by that have a top-class debugging experience for the users. Yeah, on the downside, you need expertise in low-level code. It's definitely more challenging than the other approaches, I would say, at least if you don't have that kind of experience yet. And so the effort to realize abstract concepts is also higher. For example, if you have object-oriented concepts in your language, like classes and inheritance, there is no concept of inheritance in the intermediate representation because that's a very low-level language. It's closer to assembler, basically. And so you have to make sure that this concept is realized. So you have to implement dynamic lookup tables, for example. Good. I want to close with just two different topics that are more on an even higher level of abstraction in the whole process, which is about language adoption and how the language evolves. And so the question here is, will these users even accept the DSLs? Because there are often discussions about it, also with talking to customers and what issues they have sometimes, talking to the users that they would like to where they would like to introduce the DSL. And yeah, I don't have a lot of time left, so just to name a few typical things that I mentioned. For example, text is for programmers, which I think for all these things that mentioned here, there is truth in it, and it's okay, and I think it's also good to appreciate the feedback. But so for this specific example, I would say yes, maybe, but I would recommend to try it at least. Maybe you will see that you can be much more efficient with this new concept than you were before with the previous tooling. Or I want to see it graphically. Okay, I think you can even combine graphics and text. You could, for example, derive a graphical representation from your textual specification. Or I want to write text, free text here. That's also possible. You can have a DSL that includes some parts that are more like free text. The issue, I think, is when you have free text, it's not formal, it's free. And so then you can't really have the same level of automatic processing as I described before. You could apply some AI magic to it, but that's a different direction then. So what I'm talking here about is about a formal approach, and so you lose some processing power in the end. Or I want feature XYZ from my programming language, can be done, but keep in mind what is the complexity level that you want to target for your users. Don't make it too complicated. I want to edit the generated code. Why? Let's try to find out what is the problem. Is the DSL not flexible enough? Or are there other issues with the tool chain that we need to solve? So, yeah, just a few examples. And then to close, I want to name 3 aspects of language evolution. The first is when you evolve your language, the compatibility is determined only by the syntax and the semantics. How all that is implemented can be regarded as, or yeah, what is behind that. So in your Langium code, for example, it can be really regarded as implementation details and can be changed, which is very nice because you can change a lot of code without breaking the contract to the user as long as the syntax and semantics stay the same. Still, yeah, you should apply semantic versioning, of course, increasing your major version when you have a breaking change. But it's often easy to add features without breaking. So you can have more new functionality, like it's often seen also in programming languages. And finally, you can use deprecation warnings. You can define your own syntax for that, or you can annotate internally some features as deprecated so that the users will see in their editor that a certain feature should no longer be used, and you could even provide a quick fix that automatically transforms it to some new form so to help them migrate to the new version. So this is also a really nice way to evolve the language. Yeah, that was it from my side. I want to say thank you. We have a booth over there on the other side of the hall, so please come to us and let's continue discussions. And I think there are a few minutes left for questions. Thanks a lot.
Hello? Is the language specification general enough to represent typical languages like Java, C++, BASIC?
Well, C++ particularly is a super complex language, and even more, it's one that cannot be represented with the approaches described here because of the limitations of the parser that we use. That goes even deeper, much deeper than I intended on this more high-level talk, but the frameworks that I talked about are targeting domain-specific language design and not this general level programming language. If you want to have a parser for C++, you would not do this with this tooling. You shouldn't do it. You should really, I mean, there shouldn't be a reason to do it, but if you want to do it, you should start from scratch, write a handwritten parser, because otherwise you won't get the performance requirements for that kind of language, because they are just too complex.
Is there an intuitive way to guess whether it's the language is dumb enough that you can model it?
Model it, you mean that it's easy enough for the parser to process it?
Yes.
I think after a while you develop that intuition. It's hard to summarize in a few words, I think. But yes, so it's possible definitely if you work with that for a while to understand the approach the parser is taking and then to derive an intuition of what can be done. That is definitely, yeah, that's the way it works. You start, then you find the first errors, and after a while you understand how you should do it differently, maybe.
Thank you.
Any more question? No, then thanks for listening and enjoy the rest of the conference.